My dear students, today we are trying to take one more most important topic of planning tool. This is supposed to be the second one after bar chart and critical path method, and then this is called to be PERT, P-E-R-T. This is called as Program Evaluation Review Technique. PERT means Program Evaluation Review Technique. So this is another way of doing network analysis. It can be done in so many forms. So this is one of the most important tool. The basic difference between the CPM and PERT is that in CPM we have in between one event activity A and another event say I, J, we have one time estimate, that is 5, as we have taken in the last numerical example. So one time estimate is given in CPM. So this is CPM, critical path method, where one time estimate is being used, that is 5. The only difference between CPM and PERT is that here you have one time estimate, here you have 3 time estimates. As I told, these 3 time estimates, they are called to be T0. This can be taken as T0. This can be taken as Tm. This can be taken as Tp. So 3 time estimates are given on the network or in a tabular form, whatever it can be. So I have told that from this 3 time estimates, you have to get one more T, that is the expected time. That can be computed using these 3 values, T0, Tm, Tp. As in the last class, I have shown that there is a formula, T0 plus 4Tm plus Tp, all divided by 6, you get T. Then these 3 time estimates can be converted to 1 time estimate. Then the problem will become, a PERT problem will get converted to a CPM problem. The rest of the procedure is same. That is calculating the critical path, calculating the total project time, they are all same. The procedure is same. Only difference between is that here you have 1 time estimate and here you have 3 time estimates. Now you may ask me one question, why this is like this? Why 3 time estimates we have to follow and why 1 time estimate has to be followed? The reason being this, once we give this one as 1 time estimate, this whole process will become a deterministic process. When we have a 3 time estimates, because optimum, the optimistic time is involved, most likely is involved, pessimistic is involved, this particular problem will be converted as a probabilistic problem. So PERT is called to be a probabilistic analysis, CPM is called to be a deterministic analysis. This is the basic difference why we have to follow. Now again you may ask me why this difference to be taken care, where this will occur. See, it will occur mostly in the research projects. PERT will occur or can come across in the research projects. CPM can come across mostly in the building projects. And mostly deterministic project where the end is final, end date is final. Here the end date is not final. That means it is repetitive in nature or it will be going on prolonging, like a missile project, for example, like a rocket. All these things they are called to be research projects. Where they will end, we don't know. The ending point, the ending date, we don't know. Here the ending date, the final completion date we know. Here the completion date we don't know. That is the reason why this is called to be a probabilistic in nature. This is called to be a deterministic in nature. Now I have considered here a simple numerical example again. We will start numbering. This one, this is 1, this will be 2, this can be 3, this can be 4, and this can be 5. So these are the events we have numbered as per Fulkerson rule. That's what we are told. What Fulkerson rule says, we have to number from top to bottom in clockwise direction. Either activities or event numbers, they have to come in that direction. The arrow as I have shown. So it should be in a clockwise direction. Now I already marked on the activity T0, Tm and Tp. For all the activities you can see. This I had considered it as a numerical example. Now only one difference you see between the project, the problems what you have seen before and this is there, that there is a D dash. This is called to be a dummy. So there can be some activities in research projects and also in CPM dummies. There can be one dummy, there can be two dummies, there can be three dummies. Now why dummy is being used? In order to create a interdependency of 4 on 3, a dummy is introduced. So this is called that 4 is constrained by 3. 4 can start only after 2, but 4 is constrained by 3. This is what dummy says. Normally we provide many number of dummies initially, and then as the project gets involved, we can reduce the dummies. Dummies will take only 0 resources. There are no resources either in CPM or in PERT. There is no resource given for the dummy. Dummy is only used under two conditions, either to satisfy the logic or to satisfy the grammar of the network. You please understand that in order to draw a network, there is a grammar. As we follow in English, there is English grammar. The same way there is a network grammar. I will come to the rules of the network grammar in maybe one of the next classes. But dummy here is used only to complete the logic. Now, when we do that, what we are supposed to do, we have to calculate TE first. Only once you calculate TE, then this problem will become a CPM problem. Then we can calculate the critical path. So I have written here I and J, event I and event J. Then I am writing T0, because there is no one-time estimate. You have to put 3-time estimates, TM and TP. These are the 3-time estimates now. Now you fill whatever 1, 2, oh this is written here, T0, this is written here TM, and this is TP. Okay. Now coming to the 1, 2, it is written as 1, 7. I am just transferring the information from the network to the table or table to the network, vice versa, whatever it is. 2 and 3, you can see there, 2-14-26. 2, 4, this one 258, 258. 3, 4 is taken as a dummy, so we can write as dummy, D. Then 3, 5 we consider as 7, 10, 19. Then 4, 5, the last one, 5, 5, 17. 5, 5, 17. Now what I have done is, I have transferred all the information from the network onto the table. Why? Because in order to, I want to calculate TE. Here. What is TE? The formula what I have given? T0 plus 4TM plus TP by 6. This is the formula given. Now using this formula, now you calculate for the 1, 2, what is T? For 1, 2, I will show one example. It is 1 plus 4 into 7 plus 13 divided by 6. So how much it is? 28, 29, how much? 4 into 7, 28, 29, 39, 42. So that will be equal to 42 by 6. 42 by 6. That means 6 sevens are 42. So you will get 7 here. This will be equal to 7. So just whatever you get, you write here, and then now you transfer this one-time estimate now here 7. I hope it is clear. First you transfer all the information from the network to the table and try to use this formula for activity 1, 2. I have used 1 plus 4m, that is 4 into 7 plus 13 divided by 6. You get 7. This 7 days or whatever unit is given, you transfer here, this becomes the TE. Now same TE, because 3-time estimates, now it has become one deterministic time estimate. So this 7 has to be shifted here onto the network to calculate the critical path easily. Likewise, 2, 14 plus 26. So how much it is? 14 into 4. Just a minute. Yeah, it will be, now I'm just trying to calculate. 14 into 4 plus 2 plus 26 divided by 6. So it will come as 14. So use here 2 to 3, that is 2 to 3, you transfer here 14. It is luckily coming as center, but it need not be sometimes. It will not be, it will be different. 258 now. 258. 4 5s are 20. 20 plus 10, 30. 30 by 6. So this becomes 5. So this becomes 5. Now the similarly same way, 3 5, 7 10, 19. So how much it will be? 7 10, 19. 40 plus 19 plus 7 divided by 6. So you get here 11. So this will be 11. Which one? 3 5. So 3 5, you can see here I did not get 10, I got 11. Because it is 10 into 4 into 10, 40 plus 7 plus 19, 66. So divided by 6, it is 11. The last one, 20, 37, 4 5s are 20, 20 plus 17, 37, 37 plus 5, 42. So that will become 7. So this is also becoming 7. So you can see that though here you got 7, 7, 14, 14, 5, 5, but here you got 7 instead of 5. So depending upon the calculation only you have to take. You cannot assume that as a middle value. So once this is over, you can circulate this, make it a circle, 5, then 11 and 7. Because these are the deterministic time estimates. Now we are not going to calculate any slack or float for this particular PERT problem. We are not going to calculate that. Now what happens? Next thing what you have to calculate is variance for the critical activities. Variance will be equal to Tp minus T naught divided by 6 whole square. We need to calculate the variance and standard deviation. I will tell you why those things are to be calculated. Now this last column will become variance. The last one. Now here there is a trick here. In order to save your time, first you need to calculate the critical path, then only you calculate variance only for the critical path, not for all the activities. So that's why you stop there and go to make critical path. Now 0, this will start on 0. This one will become on 7. By this time I think you should be expert to calculate the critical path. This one will become 21. 14 plus 7, 21. Here it will be 7 plus 5, 12 from one path and 21 from another path. So you have to take maximum, so 21. That means you are coming this way. Then 21 plus 11, 33. 21 plus 7, 28. So this has become 14 plus 7, 21, 21. 7 plus 5, 12. So it will be less 21. And then 33 is coming from this side. 28 is coming from this side. So take the maximum 33. So this will be 33 minus 11 is 21. 33 minus 7, how much it is? 26 here. Then while coming back, there are two paths. One path coming here, one path coming here. 21 minus 14 is one side 7 and 26 minus 5, 21. So you need to take the minimum, that is 7. Now 7 minus 7, 0. So this is how you have to calculate the critical path. I hope it is clear. In case if it is not clear, then I would like to explain. Now, what will be the critical events now? This is a critical event. 7 and 7, slack is 0, so critical event. 26, 25, there is a difference of 5, so this is not critical event. 21, 21, this is a critical event. And 21 plus 7 is 28, so but it is 33 here, so this is the critical event. Now critical path will go like this, make 3 lines, it is going through this, it is going through this, you can see that. So what is the critical path now? Critical path is 1 dash 2 dash 3 and 5. And what is the total duration of time? TPT is 33. So this is how you need to calculate critical path. I hope it is clear up to there. So from the network, once you mark the critical path, remember that sometimes dummy also can be under the critical path. It happens sometimes. Of course, it depends on the numerical problems, how it is given. So 1, 2, 3, 5 is the critical path now. So round it off here, 1, 2, 2, 3 and 3, 5. These are the only critical activities. So this is critical activity, this is critical activity, this is critical activity. All others, they are non-critical. Like for example, C is non-critical and 3, 4 is dummy, that is also non-critical. E is also non-critical. So this is how the critical activities are marked in the table. Why? Because we need to calculate the variance. That is the reason why I am marking the critical paths. Now variance is Tp minus T naught for the first thing. For example, 1 to 2, 1, 7, 13. So 13 minus 1 is 12. How much it will be? I will show for 1. See, for activity 1, 2, sigma square will be equal to 1, 7, 13. So 13 minus 1. 13 minus 1 by 6 whole square. This one will become 13 minus 1 is 12. 12 by 6 is 2 square. So that will be equal to 4. 2 2s are 4. So like that you have to calculate for all. Now write here 4. That is the sigma square, that is the variance. How we have calculated? Tp minus T naught. 13 minus 1, 12. Formula says divided by 12. Divided by 6. So 12 minus 6 is 2. That becomes 2 square. 2 square means 4. Then coming to the 2, 3. What is the value? 26 minus 2 is 24. 24 divided by 6 is 4. 4 square. 4 square means 16. I hope it is clear. Any doubt in that, you can ask me later. You can DM. 3, 5, 7, 10, 19. 19 minus 7. How much it is? 19 minus 7. 8. 8 by 6. 8 by 6 is 8 by 6. 8 divided by 6. That is 1.3 into 1.3. That becomes 1.78. So that becomes 1.78. So whatever value you get, you have to put it. 19 minus 7. Again I am explaining. Please listen.